explore electronics. In the previous video, we have already covered the topics such as type qualifiers, storage class specifiers, variable initialization, and constants. So, in today's video, we are going to cover the major and important concept from chapter 3, that is operators and expressions, the most accepted questions in your exams. So, now open your book and take down the key points as we go. The notes will be really help you during your exams and act your quick revision guide. So let us start with the first concept, that is operators. C is very rich in built-in operators. In fact, it places more significance on operators than do most other computer languages does. Okay, there are four main classes of operators: arithmetic, relational, logical, and bitwise. One by one, we are going to study these topics. In addition, there are some special operators, that is assignment operator for particular task. Now, let us start with the assignment operators. Assignment operators is nothing but like general meaning of assignment is for assigning something, means giving a task. In the same way, assignment operator is nothing but an equal symbol. It is used to store a value in a variable. It can be used anywhere in an example, expressions, right? Now the syntax is variable is equal to expression. This is the syntax of assignment operator. Now the left side must be here, this is the left side and this is the right side. Right side must be expression and the left side must be variables. Equal sign means for assignment. This is an example. This is a variable name and then okay, here this is an assignment operator. Now left value, item on the left side, that is variable, R value, value or expression on the right side, means the left side and right side, it is also called as L value and R value. That is nothing but left value and the right value. For example, x is equal to y plus 5. I'll write here x is equal to y plus 5. Here, this is called as L value because it's on left side. This is an assignment operator and y plus 5, it is in right side. That's why it is called as R value. That's what here given. Okay. Now, type conversion in assignment. Now we have learned about assignment operators, but how we will convert means how assignment operator is used for conversion. When variables of different data types are used together, type conversions happens automatically. In the assignment, the right side value is converted to the type of left side variable. Now let us see with an example. Here index char ch float, here int ch is equal to x, means the int it is converted into a char, float converted into a int, char converted into a float, and int is converted into a float, means in this direction it is converting. This is what we will call it as type conversion. Here data loss can occur when converting from larger to smaller type, means when the data is too large and if you want to convert that into a smaller size, then the data loss can occur. For example, int char some bits may lost, because here it is like coming from higher to lower, long. Here the char storage value is 1 and for int is 2. Now it is coming from 2 to 1. So some bits may be lost. Here long, the value is too big. Okay, int only 2. Here, the high bit may be lost, means the chances are more high in this situation. Now, conversion only change the form but not accuracy or precision. Means it can change only the form but it can't change means the accuracy and the precision value. Some compilers treat this char as always positive, others as signed. Use int, short int or signed char for safety. For safety purpose, you are writing your program while you use this kind of thing. Okay. Now for complex conversions like double to int, here it is too big and it is converting into an int, that is 2, right? Here the data loss can occur. So for this type of complex conversion, we are going to do step by step. That is, how can we do that? First, we will convert double to a float and float to a int. Now, for example, like how we want to, if we want to succeed something, we want to go one by one, like step by step. In the same way, it is in a reverse case. If you want to convert a large thing into a small type, now here you want to convert step by step, like the double flow in. Okay, now multiple assignment. Like you can use one value to several variables at once. Example, x is equal to y, z is equal to 0. Here, the value of x is what? 0. The value of y is 0. And the value of z is 0. Instead of writing this much, easily by using assignment operator, we can write this as, sorry, x, y, and z is equal to 0. That is a multiple assignment. Okay, and the next one is compound assignment. Here it is shorthand, means it is useful to simplify repeated assignment. Example, here now this is a normal thing. X is equal to x plus 10. Let me take an example. Let me consider the value of x is 2. Now the x value will be 2 plus 10, that is 12. Okay, instead of writing like this, by compound, we will get a same result. Means x, for x value, you add 10 and give me the total value of x. This is what the meaning of this one. Here also we will get the same value, that is 12. Okay, and variable is equal to variable operator explanation can be written as variable operator is equal to expression, and it works for all binary operators. Here are some examples of the assignment operators with other operators like multiplication, division, and additions. Okay, now that's all about the assignment operators. Now let us see arithmetic operators. Arithmetic operators include addition, subtraction, multiplication, division, and this is a modulo operation. And this is like adding again, subtracting. Okay, we'll get to like incrementing, decrementing. Okay, we will understand all these operators with an examples. Here, to make you people understand very easily, I have made a chart over here so it can be understood very fastly. Okay, here plus addition symbol and how we are going to use, and note what it does. It adds two numbers. Same way, here negative, the subtraction, it negates a number. Multiplication, it does the multiplication operation. Division, division gives quotient. Here it is important to remember, don't get confusion for division and modulus operation, because division means it gives output only the quotient. Here modulus, it gives me a reminder. Okay, for example, 2 by 2. I'll get, here it is a division operator. I get it as answer 1, and this is a quotient. If I do the same way, 2, 2, I'll get an output as 0, because here the remainder is 0. That is 2 ones are 2. What I get remainder? 0. This is what the modulo operation is. Okay, and plus plus. It's incrementing. Incrementing means adds 1. Decrementing means subtracts 1. Okay, here you can see another variety of thing, that is plus plus x and x plus plus. Here plus plus means increment. If we, this is a variable, and if we write it early, means before the variable, it is called as prefix. Pre means before. And after the variable, if we write the plus plus symbol means that is incrementing, we will call this as post, means postfix. Postfix. Okay. Now here is an example. Here the minus multiplies is operand by -1, that is any number preceding a minus sign, switch it again. Okay, the increment and decrement operators. Here just it is an example. Here it displays 2 and it is a reminder and it will display as I mentioned in the previous slide by taking the examples of 2 by 2. Here they have given in the form of program. For exam purpose, you can write this program. Okay. For understanding, I have given take a simple example. Okay. And the next one is increment and decrement operators. As I mentioned, x is equal to x plus 1, the same meaning, and plus x is also same meaning. That's what we will call it as prefix. And this is for incrementing, and for decrementing also same symbol we will write. There is an increment and decrement operators may either receive, that is prefix, and follow, that is postfix. Remember these words because while asking questions they may include these words to make you confusion. Okay, remember this. For example, x is equal to x plus 1. It can be written as plus x or x plus plus. Both remains the same. Here it is an precedence of the arithmetic operators highest to lowest. Okay, if they ask to explain about, okay, that's all about the arithmetic operators. If they ask question like explain arithmetic operators, make sure you write first definition of arithmetic operator and tell some points like key points and write that chart and explain each operator with an examples. So if you write all these points, you will fetch a full marks. Okay, and the next operator is relational operator. As the name itself says, relational operators means which is used to compare two values. If the comparison means the output is true, means the fact, then it is a true or else false. Now, operators meaning example result. Now, I'll take one example and I'll explain if the number is, let me take it as greater than. If 5 is greater than 2. Is 5 is greater than 2? Yes, you are right. Yes, it is greater. Then the answer will be true here. That is 1. Is 10 is less than 3. 10 is less than 3? Huh? No, right? Then the output is false. Then it is a 0. That's about the relational operator. And the next operator is logical operator. Logical operator is used to combine relational condition. In previous you have studied relational operator. Now to combine those, we will use logical operators. The logical operators are and, or, not. And these are the symbol which are used to indicate. And here in this table it shows the relational and logical operators means the truth table for logical operators, p value, q value. Here p and you know the and truth table, right? And is nothing but a multiplication. If 0 means 0, if 1 means 0. If 10 means 0, this is A and this is B and this is Y. And if 11 means 1. Now let us apply this over here. 0, 0, 0. 0, 1, 0. 1, 1, 0. 1, 0, 0. This completes and operator. In the same way, here or operator and here not operator. Not operator means the complement one. If it is 0 is given, 1. 0 is given, 1. If 1 is given, then 0. That's what not operator is. Here both lower in precedent than arithmetic operator. That is, in expression like if 10 is greater than 1 plus 12, then it is equivalent to. Means first we will add these two things, that is 12 plus 1 13, and we will check for a condition. Okay, and here is also another example given. Now here you can see, let me erase this. I think you hope you have taken that. Here you can see the precedence of relational and logical operator from highest to lowest, and make sure you write the precedence because it is given in your textbook also. So make sure you write this part also, so you'll get your full marks. Okay. And the next operator is bitwise operator. Bitwise operator refers to testing, setting, and shifting the actual bits in a byte or word, which corresponds to standard char or int data type or variant. Okay, but you can't use bitwise operator in float, double, long double, wide, or other more complex types. Okay, bitwise operation find application. What are the applications? It is used in modern programs, disk file, and print routines. Okay, and it can produce any numeric result, not just 0, 1. It can provide any numeric values. Okay, for example, if I is equal to 1 multiplied by 2 divided by 2 means here it is a rotational operator. Here see, bound by same truth table as their logical equivalent, except they work bit by bit. Here, as the operator word says, here it works means it operates bitwise. Okay, here PQ 0 is a like 0 0 0. For 1 0, we will get it as 1, and for 1 1 we will get it as 0, like this. And this is the bitwise operators list and with their action. If the have in the previous slide I have shown the example by using these operators. If this is mentioned like this, then it's the shift right. In opposite direction, that is shift left. Okay. Now, again, here another important concept, that is parity bit. Here it is an extra bit added to a byte to check for transmission error. So the parity bit is used. A byte has only 8 bits, okay, and the 8th bit is called as parity. And the remaining 7 bits, it stores the actual data. Okay, now let us understand with this an example. Here, this is the A value with the parity bit, means the original value of A here is, let me write here, 0, 1, 3, 5 zeros and 1. This is the original value of A. As the parity bit is present, I'll write it as 1 in place of 0. That's why here I have mentioned A with parity bit. And 127, mask. Okay, we can write like this. If we do a AND operation over here, we will get again a data without parity bit. Okay, here CHM removes used for remove the parity bit by setting the 8 bit to 0 and original 7 bit ASCII value is preserved. Right, here parity bit is used and later it is removed. Okay, and then next is left, means shift right and shift left, and how to use that, the variable and the number of bit position. If x is, it is number of bit position, means how many times it wants to shift in a series. Okay, that's what the meaning is. And the next operator is compact form of if-else operator. Here the syntax is condition, question mark, expression 1, expression 2. It's like if not, this next one is else. Like this condition. Here let me take it as an example. X is equal to 10. Here it is a this operator. By using this operator, we have written this code. But same code can be written in the form of if-else statement. That's what we will call this operator as compact form of if else. See, if y is equal to x greater than 9, if means perform means give 100, if not 200. In the same way, if x is greater than 9, y is equal to 100, hence y is equal to 200. That's this operator. And the next operator is pointer operator. The pointer operator hashtag. Okay, this what we'll call it as pointer operator, and it is used to access memory address and values. And the declaration of pointer will be like this. It is used to fetch the address. It is used to fetch the value at address. Okay, suppose I am writing like this. Now I am gets memory address. Here the memory address of A, we are fetching that data. If we use hash A, we are getting the value from that address. Okay, that's what the meaning is. And the next type of operator is compile time, that is size of operator. It gives a variable or data type. Here there is a syntax, size of variable or size of type. It is evaluated at compile time and return unsigned integers. And why it is used? Because it is used for a portable code. Okay, here it is an example. In text printf size of x, here the size of int is printed. Okay, and here the size of double is printed for this character. And the next operator is comma operator. It allows multiple expression in a single element. X is equal to your example, here multiple operator, right? Here assignment operator, arithmetic operator, that is addition. Here both are combined by using comma operator. Okay, that's why it is called as it allows multiple expression in a single element. And the next operator is dot and arrow operator. This operator is mainly used with structures and pointers to structures. Even in your syllabus also structures, pointers, strings. That modules are included. Deeply we will dive into it in the next upcoming modules. Okay, here I have given an examples to, that is dot and arrow. The pointer is equal to salary, you can see, and the emp dot age, which is equal to 25. It is used with structure and it is used with pointer. It means accessing a memory, and the arrow indicates it access member through the pointer. Okay, and the last operator is the bracket, parenthesis, and the square bracket, and it always starts at index 0. Which one? The array indexing. Okay, this is a parenthesis which is used for changes precedence. Means A is equal to, let me take it an example, 2 multiplied by 3 plus 2. It means we will add first, that is 3 plus 2 is equal to 5, then later we will multiply with 2. Okay, array indexing, here it always starts at index 0. It means if I write A of 2, then the memory value means how many numbers I can include, that is 3. Means it has 0, 1 and 2. Always it starts with 0 indexing. Okay, if I am writing 3 here, means I can what put or include numbers or four values within. That what it means. Now the operators part is completed. For summarization, I have included here summarization of table, means here category, the operator's name, and what all the operators comes under this particular thing and why it is used for. I have given in a table. I'll wait for a second. Please just take a screenshot of it. Now let us go to the last concept of this module, that is expressions. Operators, constants, functions and variables are the constituents of expression. An expression C in any valid combination of these elements. Okay, the expression means it's nothing but a combination of, we have learned so many things, right? What is constants, functions, and so many types of operators and variables in that local variable, global variable, all this combined to form an expression. Okay, that's what this point given. Now let us see the order of evaluation. Now C does not define the exact order in which sub-expressions are evaluated. For example, sub-expression means if this is one expression, another expression means separate expressions. Let me take this example itself. Now this is a function 1 and this is function 2. The compiler may call any of the function at first. It's unspecified. So never write code that depends on the order of sub-expression evaluation. Note down here I am mentioning sub-expression evaluation. Now this is a precedence of C operators from highest to lowest. Okay, make sure you write this. And now type conversion in expression. What is meant by type conversion? We know about the data types, right? Converting one data type into another form of data type is called as type conversion. Now the compiler converts all operands up to type of largest operand. That's what we'll call it as type promotion. When operands of different data types appear together, when it appears together, then C automatically converts them to a same type before operating that. Okay, now let us see integral promotion. It means all char and short int values are automatically promoted to int first. Means char and short int converted into a normal int first. Then later it proves operation. It may be arithmetic, logical, whatever it was mentioned, it does that work. Next one is type promotion hierarchy. If operands differ, means int, float, double, if includes more than many types, then a smaller type is promoted to the larger type in this order. It is in the next slide, I'll show you. The compiler converts all operands to the larger type present in the expression. Here it is a special case. If one operand is long and another one is unsigned int, here long it is a big thing. Unsigned int is a small, like the storage value. Now the unsigned int value cannot fit the long value, right? If this is a small box, how can it hold a big box like this? Right? So both the operands are converted into unsigned long. Okay, this is a special case. Now this is a like order how we are going to convert. As I have mentioned, same thing mentioned in a words format. That's it. Now I have taken example that is type conversion example. Here it is a code. Just how we will do conversion. First ch it is promoted to int. Ch it is promoted to int and ch it is promoted to int means the output and again it is promoted to double and final result we will get it as double. What you are seeing here same thing have means I have written in a text format. That's it. Okay, this is about the type conversion. Now let us understand cast. Like we can force in expression to be of specific type by using a cast. Now the general form or the syntax of cast is first we will mention the type and later we will mention the expression. Okay, here is an example. This is a data type that is float which includes decimal value and x by 2. The division operator, this is an expression. Okay, casts are technically operator. As an operator, a cast is unary, has same precedence as other unary operators. That here example is given without casting and with casting. Okay, here see floatex, floating division, integer division. I am using casting here. The cast operator in unary as a high precedence. Now, the last thing is spacing and parentheses. Now you can add tabs and spaces to expression to make them easier to read. For example, the following two expressions are the same, means spacing and parentheses can be added for to make the program to look easily. Okay, here you can observe nothing is changed, only left after each character or a word, one blank is left. Both remain same. That's what we'll call it as spacing. This is also another example. Here, here we can see the spacing. Importance of spacing means example of spacing, and this is an example of parenthesis. Okay, see if you see this, it is difficult to understand also and difficult to calculate also. But when you divide this thing in the form of like this by using a parenthesis, it is easily understandable and easy to calculate also, and it is easy to compile to. Okay, that's all about the spacing and parenthesis. Okay, guys, that's all for today's concept. Now the module 1 is completed. So I hope you have noted down all the important points. And also, if you have missed any previous video, also go back and watch them first for better understanding. This completes module 1. See you in the next video.